This is a toilet. This is also a toilet. So is this. And this is the crumbling infrastructure underneath.
In the US and other places, the wastewater infrastructure is aging and it's not very well suited for dealing with a lot of the challenges of the future.
This is Chelsea Wald. She spent over 8 years researching the toilet and discovered it needs a big upgrade.
Why hasn't the toilet really changed? One of the reasons is technological lock-in. Our predecessors spent lots of money putting these pipes in the ground, and then we're also kind of psychologically locked into it. It's hard for us to imagine something different.
Technologists are redesigning the toilet to do more than what we've asked of it before.
Previous societies knew that pee and poo were valuable resources in terms of the nutrients in them. The current sewage system makes it difficult to recover that. But it would be a lot easier if we could do it at the toilet level rather than waiting for all the mixing to happen and then trying to get it all out at the end. One thing that I've seen here in the Netherlands are piloting of vacuum toilets. These use very little water and they suck out the waste and keep it separate from other household wastewater, the gray water coming out of the house. And that makes it possible to make better use of that waste. Another innovation that I've seen that's promising is urine diversion toilets. So toilets that actually separate pee and poo. These have been very hard to develop, to design, because they are awkward to use. There's a new design called the urine trap that does this separation a little more seamlessly with less trouble to the user. So the high-tech toilet of the future might be a toilet that has medical capabilities. I talked to one innovator who has made a toilet that actually images your poop and from that can determine some things about your health, and especially over time, and to alert you if there might be a problem. The first big comprehensive sewer system for removing human waste from a city was in London in the 19th century. Some of those original sewers around the world from the 19th, early 20th century are still in the ground and still operating. One big problem from some of those old sewers is they were combined sewers. So they combined stormwater with all this household water. When there's a storm, even if it rains a little bit in some places, the sewers overflow. There's a couple of ways that cities are dealing with this. It's a very, very difficult problem. Some are digging big tunnels. It's very expensive, massive storage underground. Some are building green infrastructure above ground to absorb a lot of that storm water so it doesn't even go into the sewer. And then some cities are making their sewers smarter. South Bend, Indiana have a combined sewer. They've started putting these, movable devices, remote devices into their sewers. And they've been able to reduce the number of overflows a lot without actually having to dig any extra tunnels.
While some cities are making sewers smarter, other cities are reimagining the sewer as an energy source. In Vancouver, a sustainable energy system was used to heat the city's Olympic Village.
You can also start to harvest stuff from sewers. Kind of works like the reverse of a refrigerator. It uses a fluid to capture the heat. And then that heat can then be transferred into a distribution system to run through the building, just like any other heating system. From the perspective of someone in the building, they would never know that the source of the heat was sewage. Many cities already have a big mix of sanitation technologies. That diversity can actually make cities more resilient in a way. So if you can say, as a city grows, instead of expanding the sewer system, it might make sense instead to introduce building scale systems or district scale systems, or if there are areas where it really makes sense to have on-site sanitation because it's kind of more rural, you could introduce systems there that make sense, ecologically for that area.
Wastewater treatment plants take everything we dump down the drain and toilet, filters it, and uses microorganisms to clean the water.
One of the problems that wastewater treatment plants face is the residual sludge that comes out of this process. But there's people who are now looking for new ways to make use of this sludge. One is to take that sludge and turn it into a kind of biocrude that can then be used as a transportation fuel. In a lot of places, people have been inadvertently drinking recycled, reused wastewater for a long time. So these programs are called indirect potable reuse programs. Orange County was the pioneer of this program. They actually clean their water to drinking water standards using advanced technology, and then they inject it into an aquifer. And then on the other hand, you have direct potable reuse, and that would mean taking the cleaned up effluent and putting it back into the pipeline directly as drinking water. There is a fear of the yuck factor or the ick factor, which has held back these programs in the past. There is a big trend for pilot projects for direct potable reuse all over the world, but especially in the United States, even in the last year or two, it's just going to be one of the most reliable sources of water that's available. And you'd rather have direct potable reuse water than no water coming from your tap, that's for sure. So in writing this book, I came across just a wide variety of people working on all different aspects of the toilet, from the design of public toilets to the design of the toilet bowl, to improving sewer systems, to improving pit latrines, to improving wastewater treatment, to using the products of wastewater treatment. The toilet is really one of the most fundamental technologies that underpin human society. And if you want to think about it poetically, we are connected to each other as humans and to the planet through the toilet. So it is so important that our toilets are good, that they're healthy, that they're sustainable, and that everybody has access to one.